Hello and welcome, dear friends. A new format, a new attempt this time. We have researchers who are experts in their field. Today, Ovidiu Călin discusses artificial intelligence.
Ovidiu Călin graduated from the University of Bucharest's Faculty of Mathematics. And since he finished mathematics in the last century, he studied in Canada and then in the United States. He was also a professor at Princeton University between 2016 and 2017. And since 2002, he has been a professor at Eastern Michigan University, where for some time he has also been a full distinguished professor. His field is differential geometry. But he says he became out of necessity a specialist in artificial intelligence. And in 2020, he published a book called Deep Learning Architectures, which has become one of the reference books in this field. Welcome, Ovidiu. What is a large language model?
Large language model. In short, a large language model is an artificial intelligence model trained to understand and generate text similar to what humans write. It works in the form of ChatGPT or in the form of another name like DeepSeek or Gemini. And they're based on the notion of transformer, which is a very novel architecture invented in 2017 in the field of artificial intelligence.
Can you define for us what transformer means and what that word generative means that comes up from time to time?
The notion of transformer is a structure of artificial intelligence that is different from the others types of artificial intelligence that have been used in the past. For text generation, if at first text generation was done word by word, meaning using types of trees and arbors, each word requires another word could be chosen probabilistically. For example, the computer knows how to, or the phone knows how to complete. Each option, like going to school, work, or the movies, has its own probability, and a large language model knows how to choose the word with the highest probability. However, because this prediction is made step by step or word by word, it doesn't take into account the context of those terms. That's why sometimes the notion of hallucination occurs. So these networks can hallucinate because they think only about the next word without thinking about the past and the whole information gathered so far. This is fixed by these types of artificial intelligence called transformers, which bring to the table a new concept called attention. So in 2017, there's the article Attention is All You Need, which is an article published by some researchers in the field of artificial intelligence. It's more computer science than math, so the article isn't very mathematical. It's difficult to read for a mathematician who wants to see certain very mathematical and precise structures. This transformer structure makes it so that when we generate the next word, it connects probabilistically, meaning through a kind of attention to all the words from previously specified. For example, in a sentence, the most important word is the subject and then the predicate. And when you want to continue a sentence, these two words serve as your reference. Generative artificial intelligence began with 2014. They are also called GANs, generative adversarial networks. They were the first that invented by Ian Goodfellow, a researcher who was a researcher in different companies, student of a researcher from the University of Montreal. These generative networks are trained on data, and as output they generate outputs that do not memorize or copy the data they were trained on, but come up with something new. However, this new is a kind of new. We believe that they generate something new in terms of information, or they actually take tokens, or attributes from each, a few attributes from one input, other attributes from another input, and they correlate them. They put them in a special form, and it seems like it's something new. It's usually applied to generating faces, paintings, pictures, sounds, music, but it doesn't work that well. When it comes to generating new theories, for example in mathematics, solving a conjecture, or even inventing new conjectures, this doesn't work at this level. So, because it's not generating new information, a neural network, to put it bluntly, doesn't create anything new since a network's input information can't increase. It's like a conservation of energy or a thermodynamic information conservation principle. The information is always less than what goes in, but what comes out can be quite interesting for a human mind that doesn't have, how should I put it, is satisfied with something that doesn't resemble something that...
What makes these programs give answers that seem so human, and sometimes they're actually good. They can be sometimes, let's say, solutions to some problems we hadn't thought of, even though they were there.
That's very well put. Problems we hadn't thought of, but they were there. So the trick that makes a large language model give such human-like answers, and often very good and even correct ones, it lies in two fundamental keys. One is they are trained on enormous, huge, vast amounts of text at the terabyte level, including all books, articles, conversations, the internet, Wikipedia, much more than a human being could go through in a lifetime, or maybe even in 100 lifetimes. So the fact that it is trained on such a huge amount of information, at some point, you know how it is. If you stay with people for a long time, you become human. It's the same with them. They're able to learn subtle patterns of human language, human thinking, the way people argue, tell stories, and ask questions. They have a certain style, a structure of discourse, things like that, even though they don't think. And another trick is a mathematical trick that lies in the transformer architecture we discussed earlier, in which the so-called attention is in fact, from a mathematical point of view, it is a probability density distributed over all the words that were previously written, some of them having a higher weight than others. That's attention. That's why attention always focuses on the word with the higher weight. So that's about it. There's no trick. Everything is statistics. It's not about deep thinking, as we might think at first glance, that GPT can produce.
ChatGPT. It's a large language model, but today there's a lot of talk about artificial intelligence. Are there other models besides large language models? What's the difference between them and where are we today?
Large language models represent, let's say, the latest achievements of artificial intelligence, which are not only the latest achievements, but also the most successful ones, because they can be used by people in their daily activities. They can answer all kinds of questions, and they can translate from one language to another without any problem at all. They can summarize, they can expand sentences, they can analyze documents, they can make plans and strategies. So they are very successful, very versatile, and are used by everyone. They can even program in different programming languages. There are others as well, of course. For example, there is DLLE is spelled with two L's, or Midjourney, which can produce images from a description, from a prompt. For example, we want to write a story and we need an image. Snow White with the 7 dwarfs, then we write Snow White with the 7 dwarfs. Language doesn't matter when we say on the bank of a river, like this. It gives us 1, 2, or even 3 outputs from which we can choose the one that interests us. Other AIs can recognize speech, can synthesize voices. Maybe many of you already know that one of the big problems today with artificial intelligence, with using artificial intelligence, is deepfake, where I can synthesize the voice of a well-known person. 1 minute of real voice can then be synthesized to say anything else. So that's basically what artificial intelligence does. Now, current artificial intelligence is embedded. It is embedded in many activities we do on the internet, in browsers, in all kinds of applications. For example, all these applications, like even Excel, Word, and others, have an artificial intelligence assistant. So we're moving from classical artificial intelligence, which we've had until recently, to something new, which is an assistant type artificial intelligence, which accelerates human work and is a productivity tool.
But let me understand. So the processing is not done on words, but at some point it's done on pixels or on... There's a transition there, right?
To explain it in a way, when someone looks at a painting, when you look at a painting, nobody looks at every part of the painting or every pixel in the picture. You look at the painting as a whole, as a single unit. So this means that attention has been distributed across the painting, and certain parts of the painting that are important, for example, a person or an animal in the painting, a certain scene attracts the viewer's attention. A similar thing occurs with a large language model. So it doesn't look at every individual word, because many words don't represent or bring too much information. And certain types of words or certain predicates in that sentence contain more information, and what the large language model generates.
Tell us if it can be used in math problems where accuracy is the standard. In what way is it right now a problem or an opportunity for, let's say, the exact sciences?
As a mathematician, I apply artificial intelligence in my daily work. I'll also explain how. When I prepare my lessons, the slides that I have to prepare can be made with the help of artificial intelligence in just a few seconds, once I already have the material, or at least a vague idea about what I want to put in those slides. So preparing for the lesson, for the course, students can use it as a kind of a virtual tutor, like a friend or an older brother who can solve them. Even in exercises, of course, exercises. Artificial intelligence like ChatGPT 4.0 can easily solve high school or middle school exercises, including derivatives, integrals, and linear systems. All kinds of things we used to rack our brains over in school can not only be solved without any problem, but also explained in an extremely pedagogical way. This is a very good thing about LLMs. If you have some information, it can present it to you in a layered pedagogical way, in a way that some teachers might not be able to do so easily. The more difficult part is using it for symbolic solutions, meaning not for problems, with symbols instead of numbers, which we've known for a long time. And it was like a test for me to see if a student understood the logic or not. And ChatGPT was able to solve the problem very well. So not by judging logically, because it doesn't judge logically, but it has a trial by similarity, or by probabilistic or statistical, with other types of logic it has encountered before. So, other things in mathematics. Sometimes artificial intelligence also makes mistakes with math problems, especially with those that are harder, like Olympiad problems or research level problems. Sometimes it hallucinates formulas, but it does so subtly that someone who doesn't know better, like some of my students who use ChatGPT, come with solutions that seem correct from their point of view, but a more careful eye shows that certain signs have been omitted along the way. Advanced math problems are harder to solve with artificial intelligence. Currently, we're talking about Olympiad problems or complex research problems in which artificial intelligence hasn't been trained before. However, it is promised that in the future they will be trained on more and more difficult problems and will deliver results in this field as well. The incorporation of Wolfram Alpha, mathematics and Maple. In the background, ChatGPT will make it possible to solve many more problems than it does now.
We know, but it's helpful for others to learn too. Are watching this recording to know that, Ovidiu, you are in Romania during this period until the middle or maybe the end of the year with a Fulbright scholarship for a project that examines the use of deep learning in physics. Can you explain a bit more what that means and what you're trying to achieve?
Artificial intelligence is now widely applied in other sciences as well, in physics, chemistry, biology, genetics, engineering. In fact, there won't be a field of research that won't be affected and improved by artificial intelligence. My goal here in Romania was to develop this novel new branch of physics in which artificial intelligence has applications in physics. And I'm going to tell you about some of these applications. One of them is physical simulations, which can be done with artificial intelligence. It's important to know that simulations in physics are sometimes very costly or sometimes dangerous. By using artificial intelligence methods such as fluid simulations with the help of neural networks, different electromagnetic fields such as, for example, waves, heat, particle dynamics can be simulated with artificial intelligence. Another idea, another direction in which artificial intelligence can be used in physics is by solving some inverse problems in physics. What does that mean? Since Newton, at least we think about physics in a certain way, namely classical. We rely on certain laws, and with some help, devices, mathematical tools, mathematical instruments, we develop these laws and we solve certain problems of dynamics, of physics, and we get solutions, meaning we get data, we get trajectories. So this has been done for a very long time until artificial intelligence changed the paradigm, changing it completely. That is, instead of starting from some laws and axioms in physics, we start from data that is obtained experimentally in the laboratory. These data don't necessarily have to be 100% accurate, but there have to be enough of them as accurate as possible. Using this data, artificial intelligence can identify the equations of motion of these data. It can find certain unknown coefficients. From certain partial differential equations, it can find conservation laws of physical systems. It can find symmetries and invariants. So these are called inverse problems in physics, which unfortunately could not be solved with the usual methods. They are ill-posed, meaning they aren't set up properly in the sense of to reverse some data or to invert an operator sometimes, or most of the time is not possible. And you have to invert in the most optimal way possible in case certain data is provided. There are other things as well that can be done with artificial intelligence in physics, such as signal filtering, image reconstruction in microscopy and tomography. But these things were done before artificial intelligence with other tools. This fall, I added something new to my course. The use of neural networks, so the use of deep learning in solving physics problems, they are called pins from physics-informed neural networks. These deep learning tools are trained, but during training, although besides the data that is taken from the laboratory, they are trained while respecting the laws of physics during training. So the training is done so that certain physical constraints are respected. These being, for example, field equations, certain Lagrangians, Hamiltonians, or Lagrange equations, which are known and must be incorporated into the structure, into the architecture in question. So the applications are in all physical fields, in fluid mechanics, especially in thermodynamics, wave propagation, classical mechanics, and so on.
Hey, Ovidiu. How big is it? The hardware structure behind ChatGPT, which many of us use daily? What should I imagine? Computer farms? What should I imagine?
It's about computer farms, server farms that use NVIDIA chips. And just to give you an idea of how big it is, everything. So ChatGPT-4, which is the latest type of ChatGPT, is parameter-based, like a model. Just like linear regression, which has two parameters, the slope and another parameter, ChatGPT also has its own parameters. But the number is enormous, almost unimaginable for the human mind. It has 100 billion parameters. And these parameters are... And the human brain also works based on parameters. The parameters in the human brain are called, so each parameter is associated with a connection between two neurons, so that parameter is a kind of weight for that connection. In the human brain, this is done in a chemical way with the help of some chemicals. And these synapses between neurons add up to 100 trillion. A trillion means 1,000 billion. If the average human brain has 100 trillion synapses and ChatGPT-4 has 100 million parameters, you'll see that ChatGPT-4, while large, is 1,000 times smaller than the human brain. Not to mention that the neurons in the human brain are much more complex than the standard abstract neurons in a neural network. So yes, there are farms of computers which likely use a lot of energy in the future. And in the future, there will probably be put in a cold place like Greenland, so they don't have to use extra energy to cool the system. However, still, compared to a human brain, it's only 1,000th. It's still small, even though it's the biggest compared to everything done so far. Achievement of engineering, electrical and electronic engineering achievement, yet compared to...
I read in the press relatively recently, about DeepSeek and the models offered by researchers from China. I haven't heard anything about an original model coming from Europe. I wonder why that is.
Yes, that's right. There's a short answer if you prefer. If not, I can elaborate.
Both.
The short answer is a saying I've heard many times. I'm repeating it from what I've heard. They say that America invents, China copies, and Europe regulates. So the fact that Europe regulates so much has left it behind in artificial intelligence models. So it's about a lot of bureaucracy and many other things that I can summarize in more detail if needed.
Yes, summarize them. I'm curious.
So first of all, China, because it is led by a Communist Party, has massive funding, meaning as much money as needed can be allocated. So we know today how well we lived during the time when the Communist Party in our country allocated as much money as they wanted in the directions they were interested in. This is happening in China. At the same time, in Europe, there is fragmentation and bureaucracy. In Europe, although there are many funds, many brains, Europeans are considered the cradle of civilization. Around 300 years ago, a Chinese mathematician or scientist wrote a letter and addressed the envelope simply to Newton, in Europe, which clearly shows that in Europe, scientists were very well known. So China acts as a system controlled, while in Europe the network is decentralized in several countries. They speak multiple languages, they have multiple currencies, and it's harder to make such a big investment.
Ovidiu, what's the difference between today's artificial intelligence and the way neurons work? Can it be improved even more?
It's easier to answer the second question. Artificial intelligence not only can be improved further, but it's still in an early beginning stage. So it can be improved, and it will be improved tremendously. I'm only going to talk about a few aspects. Today's artificial intelligence and how people talk about general artificial intelligence, which will be something even more advanced than the partial AIs we have today. To be trained, they need an enormous amount of electricity and hardware. So we're talking about many kilowatts of electricity. At some point, we might reach a singularity, an artificial intelligence winter, because we might not have enough electricity to power these energy-hungry monsters that are artificial intelligence S. At the same time, the human brain, which I said is much more complex than the most complex artificial intelligence we have today. The human brain needs much less energy. So eating an apple and a banana daily can get you through the day. Moreover, the human brain trains non-stop from birth until death. We learn, it's called plasticity, the concept of being able to learn at any age. It's more noticeable at some ages than in old age. Whereas AIs, once trained, remain somewhat static. They need to be retrained on new data or augmented, which means even more energy, electricity. Today's artificial intelligence is based on the concept of the neural unit. So this artificial neuron is a unit that has two halves. In the first half, it collects information, and in the second half, it processes it. The collection of information is done from the information that already exists in the previous layer or in the network's input. And this information is projected in a specific direction, which is the direction of weights. Of weights, or of weights, so to speak. Of weights through a scalar product. So that's how projections are done in linear algebra, through a scalar product. Now this scalar product means the information of the input in a given direction. We aren't sure if this is the best direction yet, because at some point these weight directions will change and become optimized. After that, in the second half of the abstract neuron, there is a nonlinear function that twists somehow that information. So it doesn't leave it linear, it twists it, it deviates it in a nonlinear way. After that, the information leaves the neuron, and from all the neurons on the column, from that column, and enters the next layer, and so on. That's how it's done. The processing of information in this in an artificial brain. Things are different in the human brain. The neuron is a structure, an extremely complex biological structure, which I believe modern science still hasn't fully studied. And it is somehow based, in my opinion, also on a part of quantum mechanics. An artificial intelligence brain used today in artificial intelligence is more of a Newtonian thing. As he said, there are some projections, some functions activate. So everything is at the level deterministic, let's say, whereas a human brain also has something non-deterministic, which gives it a special creativity. So that's the most important difference between a human brain and an artificial brain.
Do you think artificial intelligence can have consciousness on one hand, and on the other hand, do you think it's necessary to set some ethical boundaries in the exploration of artificial intelligence now and in the future?
Before we answer the question about artificial intelligence and consciousness, we need to define the concept of consciousness, which is something very difficult for scientists to define. Maybe it's easier to define for those who do philosophy. So consciousness would mean a subjective experience for each individual, an experience of existence. Don't ask me what existence is. It's something perhaps even harder to define. But an adage said, I think, therefore I am. Consciousness also has another facet of self-reflection for the individual, a self-perception of meditation, of having a purpose in life, a certain will of your own, of being subject to emotions. So it is a phenomenological state. So it's something vast, which today's artificial intelligence not only doesn't have, but is very, very far from. So, to answer the first question, no, it doesn't have consciousness based on my earlier definition. Although it often makes us feel the impression that it has a conscience. So, because it is trained on huge amounts of human information, it can somehow mimic the notion of conscience. No, that doesn't exist. So an artificial intelligence doesn't have intentions. It only responds to a prompt. It generates text that is statistically plausible. It does things mechanically without understanding what it's doing. It doesn't have a subjective experience. Yes, there are such things. In fact, in artificial intelligence, there's a branch that doesn't deal with finding neural networks, but with a bureaucratic branch that deals exactly with ethics and fairness. Artificial intelligence. What is it used for? What is it used for? For good things. For example, artificial intelligence can be used, besides the good things we talked about earlier, for less good things as well. Artificial intelligence, based weaponry, deepfake manipulation through electronic level manipulation. And I'm probably sure they will exist, but as I said, these regulations are quite slow and it will take time. Artificial intelligence is developing at an exponential rate, while these bureaucratic regulations are developing at a linear rate. So somehow they might not catch up. So we have to wait for artificial intelligence to reach a threshold so we can understand what it is and its potential, allowing legislation to catch up. So for now, we don't have anything like that. There isn't a very clear legislation. It's a wild west of artificial intelligence, where corporations appear that use artificial intelligence for the good or less good of humanity.
People are wondering, okay, right now, ChatGPT and the other AIs don't have consciousness, but will they be able to develop consciousness? Will we be able to reach what some call the singularity? That consciousness could be a superintelligence, not just self-aware. Not only to make choices, as you said, not only to have its own purpose and opinions, but also to be a superintelligence. What do you think? Will this moment come or not?
My answer to the question about artificial intelligence consciousness was that it doesn't have consciousness yet. For now, it's a probabilistic algorithm, but in order to have consciousness, everything we know about artificial intelligence today would have to somehow change to incorporate Heisenberg-type principles, which would give it the freedom to reason freely. So not in certain So somehow to produce its own examples or to change its architecture in a certain way, just like viruses do when they change their structure to survive, something like that. But we're far from that. It's more of a hypothesis that we see in movies and science fiction novels. But what I see as the singularity is more something that will result from the misuse of artificial intelligence. So a singularity that would, for example, on Wall Street, about 90% of trading is done by bots from various investment banks. So there are no more people raising hands or shouting. Now they're artificial intelligence traders, some robot agents. And these bots are not necessarily bought from the same vendor. They can come from different vendors with different systems and strategies. And it's possible that at some point they might not understand each other and crash the entire stock market. So losing human control over artificial intelligence can lead to a singularity. A problem that could cause us great damage, such as damage in the field of electricity, air traffic, or the economy. Because all these things are calculated with the help of artificial intelligence, the use of deepfakes, manipulation, of cyber warfare. The catastrophe will not come from artificial intelligence becoming too smart and taking over, but from people becoming too naive in the way they use such weaponry with two edges.
I would like to add another question, whether it stays or not, Christy, we'll see later, but I would say let's include it. Ovidiu, you have taught financial mathematics, computational finance, and it's still a subject that obviously concerns you. Your example proves that. What do you think about the use of artificial intelligence as it is today in investments by people at home?
I taught financial mathematics in 2017. He used stochastic calculus and partial differential equations. So classical models, today we say they are classical. It was a time when I talked to someone at Princeton about using neural networks for hedging for some portfolios, and the idea was that you can't do with neural networks, with deep learning, things that we used to do in the traditional way. Now, after almost 8 years, things have changed. So the stocks, which are stochastic processes, so they have some information. So it's like a language. A stock is like a sound, like a language, like a signal. And they can be processed. Before, we used to process them with statistical methods, with stochastic methods. Now they can be processed with transformers. So a transformer can take a string of data, which is, it's the stocks, the value of the stocks over a certain period. And it can predict with a certain probability the future stock for tomorrow. So I'm sure these things are being done, although those who do such things don't talk about it, about what they're doing. They're somehow internal jobs in companies, because somehow if you say what you do, everyone does the same thing, and then problems arise. When everyone uses the same trading weapon, then problems arise in the market. There needs to be diversity of models and tools in trading if everyone does the same thing as it was done. In 1989, on Black Friday, when sales were up, the market crashed. So you have to do things differently than other people somehow. So that's why we won't hear how these things are done. There's no transparency in showing how someone uses artificial intelligence. I haven't clearly seen it done until today. but I'm sure those things exist.
And would you recommend that? Or is it also part of those apocalyptic scenarios where the singularity turns negative and could bury us all?
Have singularities existed for a long time, unrelated to artificial intelligence? Somewhat similar, for example, the flash crash in 2010, if anyone remembers. So in a quarter of an hour, the market dropped enormously, and then it went back up, fortunately, again to that level. These things can happen because of some misunderstanding between AIs among different bots, although in my opinion these bots are much more, let's say, intelligent than regular traders, and somehow they manipulate the market in their favor, meaning they understand each other. How to benefit and enter when the market dips. So somehow they think differently than an ordinary trader.
Thank you very much, Ovidiu, Călin.